I'm Kevin Shaw, Editor-in-Chief of Mopar Connection Magazine. Today we're at Energy Manufacturing following how they machine these raw gray iron castings into Mopar engine blocks. Either a 4 1/4 bore or 4 1/2 inch bore Wedge or Hemi engine block. Formed in 2009, Energy Manufacturing Limited is a critical supplier for the automotive, aviation, defense, energy, and high-performance racing industries, and serves as a vital manufacturing sibling to Callies Performance Products.
Hey guys, real quick, we got a whole mess of new Mopar Connection Magazine T-shirts for sale. They're up here at the Mopar Connection store. We're going to put the link up in the corner, and we have some really cool designs. The first one is my favorite, and this is called the Order of the Big Block. And as you can see, you're getting the full rotation of the big block firing order right here on your back. And in case you forget, you can have your buddy turn around, and you can set your firing order the right way and not mess up. Second, we've got the What Does Mopar Mean to You? And it's a whole script of different definitions that have been some of the most popular ones that we've seen over the years. It's not all of them, but it's a snapshot of some of the best ones. So show your loyalty to Mopar by wearing it loud and proud. Grab yours at the store today. We'll put the link up in the corner.
Inside of their Fremont, Ohio facility, Energy operates dozens of high-capacity, state-of-the-art multi-axis CNC machines all year round. It was at this time last year that we at Mopar Connection Magazine published the announcement that Callies Performance Products had finalized the contract to produce the legendary Hemi and 440 Wedge iron blocks for Mopar. Each block is cast locally, exclusively for Callies, using Mopar's molds and cores, and comes with an authentic Mopar part number. To the informed observer, these Hemi blocks are noticeably different from the original castings that ran from 1966 through 1971 in factory-equipped cars, and were later available through Direct Connection and Mopar Performance throughout the 1970s and 80s. Rather, these are the 2.0 second-generation blocks that underwent a redesign in the late 1990s and were first introduced in the early 2000s. Improvements to the original moldings include thicker decks and main walls, a cross-bolted front main cap, an AN-12 boss machined into the front lower face of the block that connects to the inlet side of the oil pump. This means that an AN-12 fitting can be installed into the boss to connect externally to the oil pickup tube in the oil pan. These new blocks also include larger Siamese cooling passages, provisions for those wanting to run a larger 60mm camshaft roller bearing, and an option to use either factory Hemi motor mounts or stock wedge mounts. We were allowed to spend 3 days following a Hemi block as it went from a raw casting to a completed, ready for final machining engine block. This process is extensive and consists of 6 stages or operations with literally hundreds of individual steps for the CNC program to follow. These operations or ops are numbered 10 through 60 and total roughly 10 to 12 hours of machining time and man hours. During our visit, we documented the entire process of a single engine block, which we'll be showing you today. Much of this video will be time-lapse footage set to music, with the occasional break for voiceover to explain each process. We'll begin by following this block as it enters this giant 6-axis CNC machine to prepare for its first op, or what they call Op 10, which will machine much of the bell housing and timing chain cover surfaces, the oil pump inlets and pad, and much more. After the first operation, or Op 10, is completed, the engine block is hoisted out of the cradle, blown clean of any remaining metal chips, and thoroughly examined. This process verifies that the CNC program is executing its assignments correctly, and that each of the holes are at the proper depths, threads are cleanly cut, and each plane surface is clean. All of this must be verified and recorded on the job ticket prior to moving forward to the second operation, or Op 20, which machines the oil pan rail surface, drills and taps the holes for the pan, begins decking the cylinder head surface, opening up oil and water passageways, and rough boring the cylinders. Depending on which part number each block is assigned, Callies offers the Hemi and the 440 wedge blocks with either a delivered bore size of 4.245 inches or 4.495 inches, allowing the customer to have the block final honed to a desired 4.25 inch bore or 4.5 inch bore. Each of the Mopar blocks begins with the same casting. It's only in the programming that one of the blocks truly becomes a Hemi or a wedge engine. The specific bosses for head bolts, unique to the Hemi, are already cast in, as are the ears for the wedge motor mounts. Only in the machining process are they either milled off or properly drilled, tapped, and clearanced. It's a remarkable process meant to be as streamlined and waste-free as possible. Of the whole 3 days worth of filming, Op 20 is one of the process's quickest operations, taking nearly half the time as the first operation. You'll also notice the first cuts made to clearance for the distributor, sidewall freeze plugs, Hemi motor mounts, and oil pump. With Op 20 complete, the block is carried over to the smallest of the 3 CNC machines for what's called Op 30. This machine can handily rotate the 330-pound cast iron engine block, allowing the CNC to run through its program. Op 30 is split into 2 parts, the first being a 2-hour machining process where the upmost mounts for the Hemi heads are drilled and clearanced, as well as portions of the valley are opened up for pushrod clearance. Or those bosses are milled off and the block is prepared to be a 440. Op 30's process gets in closer than the larger Heller machines, taking smaller bites away from the block, reaching tighter spots and opening up smaller passages. Much like the chisel of a sculptor, the machining process has to whittle away at the unfinished block in increments and bites. The previous 2 operations showed large sweeping changes. Op 30 begins the smaller refinements. The second half of Op 30 begins with another round of measurements, depth and thread checking, and record keeping, verifying that the computer programs are remaining within the allotted threshold. If a block comes out of the operation and is found to be outside of the permitted tolerance, the entire process is paused, and a series of checks are implemented to ensure that the program is correct, that the tools are not damaged or out of alignment, and that the block itself is not flawed. The second portion of Op 30 is where each of the 4140 billet steel main caps are installed. Each begins with a pressed-in dowel sleeve, ensuring that all 5 main caps perfectly mate to the block each and every time. As mentioned previously, the updated Hemi design has 4 main caps that are cross-bolted, compared to the original Hemi's previous 3 main caps. Equally, all 440 wedge blocks get the same cross-bolted upgrade. Each main cap receives authentic ARP 2000 8740 chromoly upgraded hardware. Each block, regardless of Hemi or wedge, also gets a 7075 aluminum billet rear main seal, similar to those modern designs sold through Mancini Racing. The vertical bolts are torqued to 65 pound-feet first to maintain cap alignment. Then the cross bolts are torqued to 45 foot-pounds. Because the main caps have yet to be line-honed, the vertical bolts are torqued down again to 95 foot-pounds. The slowest, most complicated, and consequently most time-consuming stage of this process is what's called Op 40. Although operated on one of Energy's high-capacity Heller machines, each sequence on Op 40 requires hand measurements, double checks, and verifications, and consequently can take upwards to 6 hours to complete. And these are much more than the regular job ticket checks too. Op 40 cuts both the line hone for the cam journals and the crank journals, and the entire engine block can be ruined if tolerances are just off by a couple tens of thousands. Energy's team must manually stop the program no less than 14 times to step inside the machine with a dial gauge to check and recheck radii. Energy had purchased these twin Heller machines over 20 years ago from a machine shop in Denmark. Although a standard in high-level aircraft and performance engine machining, these machines do require regular maintenance and upkeep as they are almost always in operation. That means that tools, repair parts, and service can often be from overseas and rather expensive. Equally, the 3.5-foot long boring tool must be manually carried to the machine's chuck and installed for the line hone to be cut. Once complete, it too must be manually removed and returned to its holding spot. This tool alone was said to be over $20,000, making it both a vital and incredibly expensive stage of this operation. Although Op 40 includes the line hone for the main caps, the final hone will be completed in Op 60. This next stage, Op 50, returns the block to the first Heller machine where Op 10 was first performed. This stage sees the lifter bores be drilled and honed, all of the head bolts drilled and tapped, as well as several other holes tapped to accept the water pump, oil pump, intake manifold, as well as the oil pump intermediate shaft and more. In fact, every last hole, passage, and port is finished in this stage. All threads are drilled and tapped. Everything that remains to be cut, radiused, or milled is finished now. Thankfully, Op 50 runs through its lines of code surprisingly quick, despite its many stages. At first blush, it would appear that the engine block is ready to ship after this stage, and in many regards, it is, save for some final deburring and the aforementioned main line hone. As a small side note, those more eagle-eyed viewers will have noticed that we're not filming the same Hemi engine from earlier, but caught this 4.5-inch bore 440 wedge block instead. You can easily tell by the motor mount ears still being present. And for those wondering, the Hemi from earlier was already completed and sent off to line hone as we filmed this stage. Callies and Energy Manufacturing waste zero time getting these engine blocks machined and ready for sale. And with that, all 5 operations are completed, meaning that the engine block is now complete with its machining process and is on to Op 60, or line honing and cleaning. As it stands, the lifter bores are machined to a stock 0.905 inch diameter and at a 45-degree angle, but they are not honed. Both the cylinders and lifter bores need to be honed by the customer. Equally, all Mopar blocks, be them a Hemi or Wedge, are machined to a stock RB deck height of 10.725 inches. At this height, the deck is 600 thousandths thick. The engine block is dollied towards the front of the machining row to a line hone machine. Here, several passes will be made with the honing stones to get the main bearing journal size to a factory 2 3/4 inch diameter. Once the main journals have reached the desired threshold, the block is hoisted up and over to the chemical cleaner. All residual coolant, metal shavings, and sand casting media is thoroughly purged from the block, leaving it clean and ready to ship. There, the engine block's job ticket is submitted to Energy's administration team, matched with the job order where the customer's information will be printed out onto a shipping label. Meanwhile, the block will be bagged and packaged with the engine block plug kit, camshaft bearing kit, a pack of oil gallery restrictors, an oil pickup tube adapter, valley plugs, and a bronze distributor bushing before being sealed in a box labeled with the official Mopar Omega M logo. And that is how Callies Performance Products and Energy Manufacturing make a Hemi engine block. I'm Kevin Shaw, and you've been watching Mopar Connection Magazine. If you enjoyed this video, please give it a like, leave a comment, and maybe share it with your friends. It'll definitely help us grow the channel. And if you want more awesome Mopar content, please visit us at www.moparconnectionmagazine.com, where new articles are written and published every single day, Monday through Friday, entirely subscription free to you. We'll see you there.